Hello, this is Dr. Hart, and this is a video about energy policy. The importance of energy policy. Everybody uses energy, so energy is a relatable topic. All persons, natural persons, which is human beings, and artificial persons, organizations, need energy in order to survive and thrive. In economics, energy is a universal cost component. Its price influences the prices of all goods and services. And so herein lies the connection between energy and money. Both money and energy are universally used and universally needed in a modern society. And the price of energy, that is to say, its monetary value, is directly connected to the price, which is monetary value, of everything else in the economy. So let's talk about oil in particular before we talk about fossil fuels in general, because oil is the most important of the fossil fuels, as the means of transportation in developed countries are dependent still primarily on oil. So crude oil is the most crucial part of petroleum. Petroleum is broadly defined as a class of liquid hydrocarbons mixtures that include crude oil, but also include least condensate, unfinished oils, and products produced from refining crude oil and from processing natural gas, plant liquids, including hydrocarbon and gas liquids. So crude oil, once it's extracted, has to be refined, and one of the products is gasoline, which is used extensively in transportation. One of the things to note about oil is that oil independence, and indeed energy independence, has effectively been achieved in the United States. Do not trust all the confusing information online that talks about lack of energy independence or tries to create a kind of fog of confusion by arguing against the desirability of energy independence. And if you think energy independence is not particularly desirable or undesirable, that's fine. But it's not the same as not having energy independence as an empirical fact. If you look at the recent data for 2020, you will see that the United States actually exported slightly more of petroleum than it imported. And even though if you break this down to specific elements of petroleum, you do see that the United States imports slightly more crude oil than it exports. The difference is not tremendous and is due to a significant extent to logistics, meaning that it is convenient to export some oil and import other oil. So this is related to geographic and installation logistics more so than the inability to be independent in crude oil. If the United States wanted to be independent in crude oil, it could be independent. So now let's look at fossil fuels in general. Fossil fuels were formed somewhere between 360 million to 886 million years ago, long before the age of the dinosaurs. So I bring this up because every once in a while, people tend to argue that fossil fuels, they come from dinosaur bones, and that's just not true, because dinosaur appeared approximately 230 million years ago, maybe a little bit before then, maybe 240 million years ago, and they disappeared approximately 65 million years ago. So the fossil fuel that we use today has been created many, many millions of years before the age of the dinosaur. Oil is formed from small organisms like plankton and algae. And as I said, it's the most important transport fuel in the world today. Natural gas is formed from the same organisms as oil, but under more heat and or pressure. And in contrast to natural gas and oil, coal is formed from plants and trees. Now, of all these three crucial fossil fuels, natural gas is the cleanest and coal tends to be the dirtiest. So if you are obliged fossil fuels, if you have no choice but to use them, then natural gas would be the way to go, which explains why so many countries are transitioning their buses and trucks to natural gas, because it's cleaner than diesel, for example, or even gasoline. Now, what helped the United States to achieve effectively, for practical purposes, energy independence is the combination of three things. First, the discovery of new oil deposits, so-called shale oil deposits, and also shale gas deposits. Shale is hard rock, which previously had been impenetrable, but can be, in fact, penetrated, and oil can be extracted using a combination of two methods: hydraulic fracturing, sometimes known as fracking, and also horizontal drilling. Now, both of these techniques are very old. Primitive horizontal drilling was invented in the 1920s, and then modern techniques of horizontal drilling were invented in the 1960s, and I will actually link in the description to various videos. There are many of them on YouTube about horizontal drilling and also hydraulic fracturing with animations and much more and more pictorial than what I can do in this particular video. But what happens in hydraulic fracturing is that you inject water laced with chemicals under high pressure into the shale rock in order to create fractures and allow for the release of natural gas or oil, whatever it is you're fracking for, from the rock, to release those bits of oil and natural gas. And horizontal drilling is a technique of being able to kind of curve the drill and then send it horizontally down the shale rock. And this allows you to then frack that rock, so it allows you to reach the deep layer of rock which you otherwise could not have reached if you just try to drill straight down vertically. So hydraulic fracturing has existed since the 1940s, and like I said, horizontal drilling 1920s or 1960s, depending on how you look at it. So the combination of these two techniques and the discovery of new shale oil and gas deposits really transformed the energy picture in the United States, and that transformation has been dramatic between 2005 and 2019. So in 2005, the United States imported about 60% of all the oil that it used. And in 2019, the United States became the next exporter of oil and the world's top oil producer. In fact, the first time in many decades when the United States actually exported more oil than it imported was December of 2018. And as I said, in 2019, and to this day, the United States remains by far the biggest oil producer in the world, and of course the biggest natural gas producer in the world. But still sticking to oil, we can see that the United States is far ahead of Russia and Saudi Arabia. So I would say like almost 20% ahead of Saudi Arabia and Russia in terms of the production of oil. And then in number position number 4 is Iraq. So it goes like this: United States first, Russia second, Saudi Arabia third, Iraq fourth, Canada fifth, China sixth. So Canada is also in a very advantageous position because its economy is about 9 times smaller than that of the United States. And Canada is very well endowed in oil. It has so much of it, it actually has been exporting it for a long time. So even though population of Canada has really exploded relative to its base several decades ago, so population really grew in Canada just as it has in the United States, Canada still has a lot more oil than it needs to. So even if the United States could not depend entirely on its own energy, it could in fact have this North American energy independence with Canada included, just because of how much oil Canada has. Now, when it comes to natural gas, as I said, the United States is also the number one producer, but here the gap between the United States and everybody else is even greater, right? It's even greater. So the United States produces almost 50% more natural gas than the second biggest producer, which is Russia. And the United States produces about 4.5 times as much natural gas as does number 3 producer, which is Iran. And by the way, Canada is also among top producers of natural gas. It came in at number 6 in 2019, which is not bad. But Canada produced approximately 6 times less, 5.5 times maybe less natural gas than the United States. If you look at export share of world's leading natural gas, so by country, it's an interesting indicator, just something to look at. So in terms of exports, Russia leads the way. It actually exports 21% of all exported natural gas. Now, one of the reasons why Russia exports so much natural gas, even though it's well behind the United States in terms of its production, is because Russia's population is only 145 million people compared to the United States with estimated population of 335 million people. And Russia's economy is maybe 8 to 9 times smaller in terms of GDP than that of the United States. And Russia depended traditionally, so Russia and then the Soviet Union before Russia's independence depended very heavily on exports of natural resources, including natural gas. So that's an area they emphasize, and the United States and Qatar share second place in terms of exporters of natural gas. Leading countries by liquefied natural gas, frequently abbreviated as LNG in terms of export. Now, I wanted to mention this because liquefying natural gas is an expensive process, but it's a process that sometimes makes sense when you cannot transport natural gas for export using pipelines. Because how do you transport natural gas? Pipelines, generally. But sometimes you can't. So if you cool natural gas enough, it liquefies, and then you can transport it by ship. So not surprisingly, Australia is number one in terms of just the sheer volume, followed very closely by Qatar in terms of liquid natural gas exports, because Australia is a continent. It has a lot of natural gas, and it has a very small population compared to countries that we have specifically been talking about so far. Population of Australia as of 2021 is about 25.5 million people. So compared to the scale of Russia, not to mention the United States, the population of Australia is truly small. And even by world standards overall, it's a mid-sized country at best in terms of population, but it's a continent. And the natural gas that it has in excess of, it can export. And since there's no pipeline from the continent of Australia to someplace else, Australia liquefies natural gas and then it's exported. Advantages of fossil fuels. So fossil fuels are energy dense, which makes them very convenient to use. They contain a lot of energy relative to their volume. Second, they're cost efficient. So more units of energy per unit of money can be extracted from renewables. So they're cheaper. That's a fancy way of saying they're cheaper than renewables. And there exists already an extensive, well-developed infrastructure for extracting, processing, and using fossil fuels. That, of course, makes it very convenient in terms of end users' experience, but it also makes it difficult to replace the infrastructure. That which already exists is difficult to replace, generally speaking. Most of existing transportation in the world is tied to fossil fuels. That's as of the 2020s. Both individual and public transportation is expensive relative to individual and the public who paid to have them, to purchase them, and to maintain them. So what I mean is that if you buy a car is probably your second most expensive acquisition after your mortgage. After your home, your car is the second most expensive acquisition. So once you have paid for your car, or once you have contracted to lease a car, that's a major investment, and it's harder to get rid of it and replace it with an electric one. Although, as we are moving more and more into the world of car leases are actually on the rise. As we move there, and as people keep their leased cars for, let's say, 3-4 years, and then they get a different car, it will become easier logistically to get a hybrid or a fully electric vehicle next. But still, replacing existing transportation is expensive. Or if it's public transportation and it's fossil fuel transportation, again, it's expensive, and in some cases, you cannot really replace them with fully electric. So, like a big rig or a natural bus can so far probably not be propelled by fully electric, which is why buses have been transitioning to natural gas and away from oil-based fuels. So replacing the existing infrastructure in fossil-based vehicles is an expensive and long process. But one of the encouraging things is the experience of Norway, which has now gone to the majority of electric vehicles. And like within a decade, they went from electric vehicles being in single digits to electric vehicles being the majority of vehicles. But they can afford to do so because they can subsidize the purchase of electric vehicles, all of which they actually import from abroad. All of them are imported. But they can do it, ironically, partly because they're so oil rich and they make so much money off of oil. They have the most oil in Western Europe with a very small population. And so the country is very rich, and it can use money that they make off of oil to subsidize their electric vehicles. And so as we move forward into the 2030s and 2040s, electric vehicles will become an ever bigger picture of what we see on the roads. But that day is not here yet, because again, of the expense of acquiring and then maintaining the existing fossil fuel vehicles and fossil fuel infrastructure. Now, disadvantages of fossil fuels. First, they're non-renewable relative to human life and civilization because they take millions of years to form. That's self-explanatory. Now, this means that we will run out probably before the end of the 21st century. There are various estimates. A lot of them converge on approximately 50 years in terms of both gas, natural gas, and oil. But recent experience has shown that our estimates have actually been pessimistic. Because if you recall, or if you look up on the internet, the peak oil hypothesis, it's been around since the late 70s, early 80s, where it was actually in vogue, and it said, well, in a few decades, we will reach oil prices that are unsustainable, and so we won't be able to use fossil fuels on a mass scale in the 2010s or 2020s. And that proved to be false because we have discovered new deposits, and we have perfected the techniques for extracting those deposits. So 50 years may be actually pessimistic. The world can have more oil and natural gas deposits for much longer than that. The second disadvantage is that fossil fuels pollute the environment, and thus over time they damage human health and make life less pleasant and more difficult. Nobody likes to see pollution, to smell pollution. It's just gross. And three, the greenhouse effect. Since fossil fuels are carbon-based, they release carbon when they are burnt, and combined with oxygen, create carbon dioxide, CO2, that traps heat in the Earth's atmosphere, causing global warming. It's like using a blanket when you sleep. So the blanket traps heat, body heat, and in this analogy, of course, carbon dioxide is a blanket. So as heat gets trapped in the Earth's atmosphere, the temperature keeps slowly rising. And of course, this leads to the gradual melting of the polar ice caps. The oceans are rising. Some of our world's cities may end up underwater, like Venice, Italy, or Miami, Florida, New York City. So, well, this is not a pretty picture, and this is the side of the insanity of fossil fuels. So, on one hand, fossil fuels are great because they are relatively cheap. There's an infrastructure for their use. But on the other hand, the greenhouse effect and the damaging impact on health make their use seem like insanity. So you have this Janus-faced nature of fossil fuels. The greenhouse effects and the adverse health effects of pollution is something that will probably spell the downfall of fossil fuels even before they run out. But that's not going to happen for many decades. So as far as we can see, at least until the middle of the 21st century, fossil fuels will remain in wide use. Next one is renewables. Now, I want to talk about the advantages of renewables first before I actually talk about the renewable sources themselves. So the advantages is obviously they're indefinitely renewable. They will last for hundreds of millions of years. So the sun, as it converts hydrogen into helium, as it burns, it's kind of a natural nuclear fusion reactor. As the sun continues to do that, it grows hotter. And eventually it will become the red giant. But even before then, its temperature will become so hot that the Earth's oceans will evaporate and life on the surface of the Earth will disappear about 900 million years from now, maybe a billion years from now. So nothing lasts forever, but it's indefinite in terms of this time scale of human civilization. So we will be able to continue to use the energy of the sun for hundreds of millions of years to come until the sun finally becomes too hot and destroys all life on the surface of the planet. And then after that, about 6 billion years after that, that is to say about 7 billion years from now, the sun will probably engulf the Earth. It will become a full-fledged red giant, and it will expand approximately 1 astronomical unit. So it will just expand enough to engulf the entire Earth. So the sun will destroy us. But for now, its energy is potentially unlimited. A lot of people are very positive. Elon Musk is one of them. He believes that the solar panels can actually give us unlimited energy. We will see, and I think we'll see shortly, just in a few decades, whether this is true. Renewables are also good because they do not generate greenhouse gases, so they do not lead to pollution, health issues, and they do not lead to the global warming. There are also, and they're also abundant, so that they can drastically reduce energy costs. And in fact, energy costs themselves will go down to zero. The only cost that you would have to pay is the cost that it takes to manufacture, transport, install, and maintain those, let's say, solar panels, if it's solar, or windmills, if it's a wind farm. So renewables include sun, wind, geothermal, and hydro. So wind is self-explanatory, and I have here a picture of the wind farm. And geothermal is the energy of the earth. Geo means earth. So things like geysers, for example. The energy of the earth can be harnessed. Iceland is big on using geothermal. And hydro. Now, hydroelectric energy is today the most important type of energy in the United States among renewables. So if you look at all renewables in the United States, they are approximately 12% of all energy production. Okay? And of those 12%, hydro is about 50% of the 12%. So hydro is about 6% of all the energy production in the United States. Now, that will change over time as battery technology improves and we can better and cheaper store, more efficiently and more cost-effectively store the energy produced by the sun and the wind. So the sun and the wind will rise in importance among renewables, and hydro will decline relative to wind and sun in importance. So disadvantages of sun and wind: when the sun is not shining and the wind is not blowing, the energy is not generated. So this is what we mean when we say that renewables are less reliable than fossil fuels, because you don't need to have great weather to get energy out of fossil fuels. You don't have to have a specific weather condition like the sunshine or the wind. But with sun and wind, you lack this reliability. Now, you can say that this may be true in general, in the abstract, but there are places on the surface of the Earth where this isn't necessarily the case, like in southern Nevada, or like in Arizona, or in Southern California, where there are so many sunny days that for all practical, and we know how many there are actually, that for all practical purposes, the energy of the sun is reliable in those places, because we know exactly pretty much how many days, sunny days, you will get. Okay, so that's fine. Another problem with these renewables is the storage is expensive. So battery technology is still expensive and not as efficient as we would like. So the sun and the wind power is less reliable and more expensive than fossil fuels. That's going to change going into the second half of the 21st century as the production of fossil fuels declines, because there will be less and less fossil fuels and the battery technology improves. So the relative cost will come to par eventually between fossil fuels and renewables. And because renewables are a lot more environmentally and a lot more human health friendly, renewables have a brighter future than fossil fuels in the long term, in the second half of the 21st century. Nuclear energy. There are two types of nuclear energy you can potentially use, and that's fission and fusion. In terms of extracting energy for peaceful uses, we so far, as of the 2020s, can only do that with fission. Fission is the splitting of the atomic nuclei, and what you use is an isotope of uranium to generate, in a controlled manner, to generate nuclear power. The United States is obviously the pioneer in this field. It has been using nuclear fission power plants since 1958. And we have in the United States 56 nuclear power plants for the total of 94 operational reactors. But none has been built in decades because of the safety concerns. Now, in the United States, nuclear fission is not a major component of energy, despite all of these reactors. Some countries rely much more heavily on nuclear energy. I think France still uses about 75% of its electricity actually comes from nuclear fission. Now, nuclear fission has many drawbacks, and first of all, nuclear waste is produced, and this waste has to be then safely transported and stored to specially secured facilities. Like, let's say, if it's in the United States, Yucca Mountain in Nevada is one of those places. So an accident can happen during transportation, or facility may not be secure enough, and nobody wants to build more facilities in their backyard. So there is a problem with transporting and storage. And then there's another problem in that a single major incident can actually seriously contaminate the environment for thousands of years. One example is Chernobyl in 1986. In April of 1986, a major accident, a meltdown of one of the 4 reactors in Chernobyl in Ukraine, approximately 90 miles from the capital of Ukraine, Kiev, from a multi-million people city, almost 3 million people. A major meltdown which led to the deaths of many people, long-term health consequences, and contamination of the environment for thousands of years, and health impact which is ongoing because small doses of radiation continue to escape into the atmosphere, into the groundwater for a long time. And so the impact of Chernobyl continues. And then also we had a meltdown of the reactor in Fukushima in Japan in 2011 following the tsunami, which disrupted the operations of the reactor led to a meltdown. So the danger of a single major accident is something that keeps countries like the United States away from expanding their nuclear energy facilities, from building new ones. We had a partial meltdown in the United States at 3 Mile Island facility in New York State. That was 1977. Since then, no new reactors built. Now, the other possible nuclear energy is fusion. And fusion has not yet been harnessed for peaceful uses. It has only been harnessed for military uses. So a fusion bomb or a hydrogen bomb or a thermonuclear bomb, that's been in existence since the 1950s, since the early 1950s. But that's an uncontrolled fusion reaction. What happens in a fusion reaction is the fusing of the atomic nuclei as opposed to splitting them. So nuclei of hydrogen are fused and produce helium. In the process, mass is lost and that mass is converted into energy. Fusion is a lot more energy efficient, produces a lot more energy than fission. And it does not generate a nuclear waste, does not generate CO2, which is something that it shares with nuclear fission. Nuclear fission also doesn't generate CO2. So nuclear fusion is potentially far more attractive and could give us unlimited energy going forward. And we actually believe that we have mastered the science of how to generate fusion power in a controlled way. But the engineering challenge still is ongoing as of the 2020s, as to being able to control very hot plasma that would allow for atoms to merge, for the nuclei to merge. And we're still working on it. The two big promising projects is the ITER reactor in southern France on the border of Italy, which is an intergovernmental project. Governments of many countries participate, primarily European countries, participate in that project. And in 2025, it's supposed to start running at full capacity, not at full capacity, but experimentally. This is already a delay, partly due to COVID-19 and partly due to technical difficulties, and also partly due to bureaucratic overlap and just bureaucratic morass. It was initially scheduled to start, I think, in 2019, then moved it to 2021, and now 2025 is the target date for running full experiments. And then full capacity in 2035, so that means that in 2035, the reactor is supposed to actually generate more power than it takes to run it, and this is when we're supposed to get fusion. Actual fusion power, positive fusion power. In the United States, Helion Energy is a company in Everett, Washington, which plans to produce fusion energy. And Helion Energy is so interesting because it's privately funded. So when private investors get into it, that's an additional impetus. That suggests that it's a workable solution. So hopefully we will get to nuclear fusion. So no long-term radioactive contamination, no carbon dioxide, as I said. And if we get fusion and we get renewables, we will not need fossil fuels. So going into the second half of the 21st century, this can be quite exciting, because potentially we will be able to get rid of the pollution generated by fossil fuels. So this is it for energy policy. Thanks very much.